This is my CNC fiber laser project. This is part one. We're gonna start actually talking about what I already currently have, which is my plasma table. And really what I'm doing is I'm gonna convert my plasma table from CNC plasma to CNC fiber laser. This is built, it started actually 14 years ago with a Torchmate kit that was a welding kit. It wasn't even the extrusions I use now or were using back then. I ended up later hating that because it did not have a water bed. It just worked terribly. The motion system sucked. I went to Avid CNC, which is, this is their rack and pinion, their linear rail system, which is kind of cool and kind of weird. There's their motors, all their stuff. But then I retained the Torchmate, which is actually flash cut control system, the Torchmate height controller, and I'm currently on version 9 of flash cut. So the reasons why we're going away from the CNC plasma table, there's a couple actually. One is, one terrible one, I don't cut the entire sheet in one setting. I always cut a little bit, work on a project, cut a little bit, work on a project. And when this is full of water, it always causes these expensive sheet metal to rust. I hate the rust, right? The other thing it does is if you're cutting any holes, you can't get a precise hole out of this because the bevel of a plasma just causes a huge bevel. Draining this constantly with all the rust in it kept making this big rusty mess, and I didn't want to let that happen. So I always left this thing full and it just rusted more. And I didn't have a good way to combat this. Allegedly fiber laser, there's no water bed. You don't get one. You don't want it because the reflection of the laser off the water would be terrible. The cut is very fine and straight. And so now we can cut some fine holes. The kerf width is very narrow, which is great. And we should get rid of the rust problem, which is also awesome. So that's the reason why we're going this direction. I have some projects that I need more precision out of them. I'm tired of grinding, so we're moving to fiber laser. Let's show you what I have collected. I've been collecting parts for this. We're gonna try to move through this project pretty quickly, but it's gonna take longer than I want. We have a Max Phototronics laser source. So this is a 2000 watt laser source. This, in theory, see how this works, should cut up to 16 millimeter thick carbon steel. I've heard different reports whether it really does it that well or not. Most of what I cut is 1/4 inch, so like 4 millimeter, 5 millimeter. So this should be more than capable here. I can't run a bigger laser source because I'm on single phase 220. This is the biggest one you can run. So once you go to a 2500 laser source, it has to be 3-phase, which I don't have. We're not gonna get there. That's that. Should be pretty cool. I bought all these things from Skyfire Laser. If anybody watches Travis Mitchell's videos, he's done a lot on this stuff. He recommended Skyfire. I shopped all over trying to get the best deal I could find. And to be fair, Skyfire Laser was the best source for all this stuff. So I bought all these things from them as kind of a kit. They supplied a lot. So like all the cables, all the servo motor cables come with this. All the data cables for the different things. It all came in this kit. Looks like, e-stops for this thing. Wire to the, cooling hoses for the water chiller for this. The air assist hoses for the air assist to happen. So we have all that going on. We have the laser head. This is an autofocus laser head. The difference is between the autofocus and the manual focus is only like $200. The autofocus adjusts the beam focus. This is super critical when, especially with cutting thicker material. It'll focus one height and then it'll pierce the metal and then refocus to a different cut length or cut height. The autofocus you have to have. Otherwise there is an Allen key and you go and adjust this, and then once it pierces, you pause the laser, readjust it for every pierce. So that's really not gonna work well for most people. I don't know why they even make them. So this is an autofocus. So this is their Z gantry, so Z gantry stuff. So yeah, we got some gas controllers. We have their consumables kits, their little industrial computers, probably running Linux. It's be kind of cool there. So I think we got most of the big expensive parts out of the way. So let's now talk about my screw up. I've already made a big mistake that's gonna cost me some money. We're gonna work through it. So I was looking up all the specs for a 750 watt AC servo motors. These have encoders on the back of them so they can know the position, and the servo driver adjusts the position to make sure it's accurate constantly. Super cool stuff. I was looking up all the specs for the 750 watt, but when I placed the order, I ordered 850 watt. That's not a big deal, right? Well, it's a monster. It's an absolute monster, and it turns the 750 watts spin at a maximum speed of 3,000 RPM, where this only spins at 1,500 RPM. So this is not gonna work. So I've ordered new servo motors. The idea was I'm gonna try to use as much of the old gantry as I can from the Avid stuff. So I ordered the Pro Series Avid CNC rack and pinion kits. This is supposed to fit NEMA 23 or NEMA 34. So when you compare this, like, it's not even close. Like, not even close at all, right? It's never gonna work. This is a monster servo motor. This is 130 millimeter, they call it. The 750 watt servo motors are 80 millimeters, so much smaller. The odd thing about this, and I don't know why this is like this, and it doesn't really matter, is the AC servo motors have their own bolt pattern. So they're not NEMA 34, they're not 43s, they're not 23s. They're their own weird bolt pattern. So a NEMA 34 is typically 86 millimeter on the bolt circle, where the AC servo motor is an 80 millimeter bolt circle. So unfortunately, this isn't gonna work. So probably what I'm gonna end up doing is, I've ordered new servo motors to get that problem fixed, because these are just too big, they're not gonna work. I'm gonna start 3D printing new versions of this so that I can make it fit all these things. Yeah, so once we get started with that, I'll show that more once you get to that part. It's gonna take me probably, I think their shipping time was 2 or 3 weeks before it arrives to me. So some of that delay is just not my fault. It's gonna just be what it is. But the idea is that we're gonna still try to retain the Avid CNC rack and pinion kit and run a smaller motor. And they have a little belt that goes on here. We'll probably have to change the belt size. Has a little pinion gear. The idea is that this all goes in there and then drives the rack and pinion. I'm gonna probably try to reuse their cheesy linear rail system and not go to a traditional, MGN linear rail just to save money. I might regret this decision, we'll find out. But yeah, so what'll happen is I'll 3D print a whole bunch of versions of this until I find a version that I like, that fits everything well, meets all the constraints that I have. Then what'll happen is I'll take that design, send it to JLPCB, I think it's called, or PCB Way is another one that does it, and they'll machine this for me. I'd love to do it on my own CNC mill, but that's another project, and we need to get projects done, not build a product to get another project done. So we're just gonna go pay somebody else to mill this for me. I've used some of these services before. They're fantastic. It takes about 3 weeks to get it once I send them a file, and the cost is pretty darn reasonable. So that's the gist there. That's where we're going. I'm gonna take you along for the ride. This is not gonna be a how-to do this if you're doing this yourself. This is gonna be how I will try to give things like, hey, here's some of the wiring, here's how this gets wired, here's the voltage requirement. Try to break down some of the technical data or technical information, but by all means, I am not the expert on this. I am learning as we go, and I just wanna share it with you. Let's talk about one more thing. I also bought Skyfire sells an electronics package, all the motion control electrical stuff. They also sell a add-on service for $150. They pre-wire it. I want to show you that. I bought it, but we're not really going to use it as they intended. So let's look at that real quick. So this is their pre-wired kit. It's actually super nicely done. I'm not gonna use it this way because it's not gonna fit in the constraints. I'm gonna try to get this all underneath the bed to I only have so much room, right? If the room wasn't a space, I'd probably just make these go back to back and use them. But things just got a little bulky. What all this is the driver for the laser head focus, and these are all the additional drivers. You might notice that there's a lot of drivers here. I actually ordered this to be a tube cutter as well. And so the motion controller, which is this thing here, is their T version. So it's the AX3000T. So it's tube. So it's gonna cut flat plate and tube. The tube we're gonna add into this as we go. My intent is not to make the tube cutting work first, but get the flat plate system to work. Oddly enough, on my plasma table, I have a tube cutter for that as well, and it's amazing when you use it. Yeah, so they've done a good job. Like, you have all the different relays for all the different functions. So like a lift solenoid to support a tube, gas solenoids for on-off, controlling gas solenoids on-off, power supply for the 24-volt stuff, big circuit breakers or big relays for the laser source, circuit protection. So there's a bunch of fuses here, or circuit breakers. So it's really cool, but we're gonna take it all apart. The kit, to be fair, their wiring service is only $150. Their kit is all these little parts, just not on this board. So it's not a huge loss. Nothing compared to the servo motors I did not order correctly. So that's it, that's the deal. Stay tuned, we're gonna make this thing happen. Like, subscribe, and do all those cool YouTube things, like the subscribe button and the thumbs up. That stuff.